Okay, so today we're going to be talking about some circle stuff. Our circumference and area will come back into play. And while you thought that we were done with our circles unit, guys, the circles, they never end. So let's go ahead and write out our circumference of a circle. Formula is 2 pi r. We also know it as pi times d. Our area of the circle is pi r squared. We know our area, right, is our area of this whole shaded thing on the inside of that circle, and the circumference is just the distance around the outside. We're going to be talking about a portion of our circumference and a portion of our areas. So our idea of arc length is just going to be the crust, right, of our pizza. That's how I want you to imagine the arc length. It's that distance around the outside and only a portion of it. So to find out what that distance actually is, we're going to take our circumference and then multiply it by our proportion of that circle, or that ratio of the circle, which is our arc measure over 360, because we know we have 360 degrees in our circle, and we also have our lovely arc measure on the inside. Same idea for our sector. Here's our circle. I want us to imagine this as a slice of pizza. So we're not taking the area of this whole pizza, we're just finding the area of this pizza slice. To do that, we'll take our area of the circle and then multiply it by our ratio of that whole circle. So our arc measure over 360. Awesome. Let's throw these formulas into some example problems. We're going to do 2 example problems together, and then I'll have you try one on your own. We're taking this circle C, and we're finding the length of our arc, and then the area of our sector. So something that just got deleted off of yours is the radii. The radii is 6. Sorry for the confusion. So we're finding the arc length first. So we're going to bring down our formula of 2 pi r times our arc measure over 360. In this case, our r is 6, and our arc measure, looking inside at this central angle, we know we have a right angle here, or of 90 degrees. We simplify. 2 pi 6 becomes 12 pi. 90 over 360 becomes 1/4. Multiply numerators, multiply denominators, we get 3 pi. And then our units, we don't know them, are just units. We'll do the same exact thing for our area of the sector, which is just the area of that pizza pie, or portion of that pizza pie at least, of pi, and then radius squared times our ratio of that circle, which is our 90 over 360. So I'm going to plug in that known information, right? We know our radius, we know our 90 over 360, and then we simplify both of those. We get this to be 36 pi. We get this again to be 1/4. Our area of the sector is 9 pi units squared. Okay, this next one we're dealing with an inscribed angle in addition to our central angle. So we're going to use our inscribed angle knowledge to find our measure of that arc. So we're going to start first with our length, just like before, 2 pi r, which we don't know, times our arc measure over 360. We're looking for that arc measure at that central angle, because that's what the measure that we're trying to find, or that length that we're trying to find. To find that, we go back to our circles unit. We take our inscribed angles, multiply by 2 to find that intercepted arc. The intercepted arc and the central angle have the same measure, so that measure is going to be 80. Additionally, we know our radii, which we can plug in, and then it's a matter of simplifying each of those. So this becomes 36 pi. I'm just going to divide top and bottom by 10, because then I'm able to divide out the 36 divided by 36, and get that arc length of 8 pi units. You can totally do this in your calculator as well. Multiply numerators, multiply denominators. If you do get a decimal value, just leave it as an improper fraction. Okay, and then for our sector, we have our pi radius squared times our angle measure, which is 90 over 3, or 80 over 360. Again, we know that radius is 18. We multiply our numerators out, we simplify it by denominators, and we'll get 72 pi units squared. All right, I'm going to pause this video. Go ahead and work on number 3. Find that area of the sector and then the perimeter of the sector, right? The distance around the whole figure, right? That pizza pie. Give that a try. All right, go ahead and check those answers. Area of the sector we find is 16 over 3 pi units squared. You can also write that as what, 5.33 repeating, right, with that repeating sign, 5 1/3, but typically you see it as improper fractions. Your perimeter of a sector, this one's a little bit different. You'll find your arc length and then add those 2 radii in there as well. So it applies our arc length information from this unit so far. Okay, we're going to head to the back to talk about our segment of the circle and talk about finding the area of that specific segment. So let's head on to the back side. Okay, so this segment of the circle, you notice it's not necessarily that pizza pie shape. It's a portion of that pizza pie shape. The whole goal, right, how we're going to find this segment of the circle is to find that area of the sector and then subtract that unshaded triangle on the inside, right? We see that we have this whole segment of our sector of our circle, which we found on the front side, but we don't necessarily need this unshaded portion, which is a triangle. So our formula per se is to find our area of the sector and subtract our area of the triangle outside of it. I'll pause it and write it on the top. So that's our formula per se of our area of the segment of the circle. We'll start with our first question, just finding our area of the sector and subtract our area of the triangle. Again, that sector is that yellow portion around the outside, right? This whole thing here. So I'm going to apply my pi radius squared. My radius is 8 times my angle / arc measure over 360. I simplify that. And I get 64 pi times 1/4. Okay, great. So that simplifies to 16 pi for my area of the sector. For my area of the triangle, this one's nice in that we have this right angle in our corner. We know our base length and our height length are 8 and 8. So to find my area of the triangle, it'll be 8 by 8, right? Base times height divided by 2. Which is 32. So my area of this segment, right, just this shaded portion here, is going to be 16 pi minus 32 units squared. All right, let's try one more dealing with our segment of the circle. This one gets a little bit more complicated because we are dealing with our isosceles triangle. So area of the sector minus area of our triangle. I'm going to start with our sector. Sorry, I just want to do some outlining here. Our sector, right, which is this piece of pie, dealing with our pi radius squared times our angle measure over 360, which when we simplify that, we get to 27 pi. Our area of the triangle, right, that area of the triangle that we're subtracting out, this is where it gets a little bit funky because we do have this equilateral triangle, or isosceles triangle, with our two leg lengths as 9 and 9. Additionally, what we can conclude about this isosceles triangle is that our central angle, right, this vertex angle, is 120, right? Central angle, same as that intercepted arc. So from there, we're going to use our base as this bottom base, and then our height as this altitude that we drop down into that base. From there, we can take that 120 and split it into 60 and 60. And then on this right-hand side or left-hand side, we have a 30, 60, 90 triangle. So from there, we can assign our pattern of x root 3, 2x. So in my pattern, I know 2x is equal to 9. Therefore, anywhere I see x, I'm going to plug in 4.5, which means my altitude is 4.5 and my little part of the base is 4.5 root 3, which means my other side of that base is 4.5 root 3. To find that area of the triangle, it's going to be base times height divided by 2. So it'll be 9.3, because I add those two together, times 4.5 all over 2. That simplified is 20.25 root 3. And then we'll tack on those inches, of course, or units. So the area of this sector, right, the shaded portion, or sorry, the segment, the shaded portion is going to be 27 pi, my sector, minus my area of the circle of 20.25 root 3 units squared. All right, let's have you guys try this number 5 to end the notes today. Something to note with 5 is that this triangle on the inside, let me change colors. This triangle on the inside is an equilateral triangle. So we can apply that formula or that knowledge about our equilateral triangle to find the area of that figure. So go ahead and work through this, find your area of the sector, write this whole yellow portion, and then subtract your area of that triangle on the inside. Okay, so our area of the segment is our area of the sector minus our area of the triangle. For our sector, the two things we need are our radii of 2 root 3, and then our central angle of 60. When we simplify that, multiply our numerator, multiply our denominator, you get 2 pi. And then for our area of the triangle, you get your base of that 2 root 3, and then you do need to apply your 30, 60, 90 to determine the altitude of that triangle. When you apply that 2x equal to 2 root 3, you'll get x is equal to your root 3, and then when you plug that back into your pattern, you find your altitude is 3. So you find that that area of the triangle is 3 root 3. We're going to learn a shortcut later on this week for our equilateral triangle. And then if you want to give 6 a shot, go ahead and pause the video, and then you could check your solution. This is the work that I provided. You certainly don't have to. This is definitely a little bit more of a critical thinking question. Not too crazy complicated, but a good question to try.